Welcome back. So last time we talked about geography as a study, course of study. We also talked about scientific inquiry. We located the Earth in spatial relationship to the solar system. And then we talked a little bit about the spheres of the Earth, or those areas that we study of the Earth. Well, the last thing, since we've located the Earth within its place in space, we also want to talk about how we locate things on the Earth. So let's talk a little bit about locating places on the Earth. When we talk about place location, we talk about the graticule. Typically, people will understand this as latitude and longitude, right? We have every place on the surface of the Earth has a specific latitude and longitude. Since the Earth is a sphere, we make use of that latitude and longitude to find things on the surface of the Earth. The Earth is tilted at 23.5 degrees, and this has an impact on some of the specific lines that we're looking at, specifically the tropics and the Arctic circles, the Tropic of Cancer and Capricorn, and the Arctic and Antarctic circles. But we can split the globe into hemispheres. Here is the globe and the graticule you'll see here. Above the equator, which is right here, is the northern hemisphere. Below the equator is the southern hemisphere. Over here on this side of the globe is what's called the prime meridian. And on the other side, opposite of the prime meridian, is what we call the international dateline. This will split the globe into Western Hemisphere and the Eastern Hemisphere. As you can tell, we divide these lines up into parallels and meridians, or lines of latitude and lines of longitude. Though one of the unique things about parallels is they never converge. Parallels basically start at the equator, and it's measured from 0 degrees at the equator up to 90 degrees at each pole. So North Pole would be 90 degrees north, South Pole would be 90 degrees south. The parallels don't ever converge, and they never cross. They do get a little bit closer together as you get up towards the pole, but they don't actually converge. Whereas the meridians converge at the poles. So here you can see this is the North Pole, and all the lines of meridians, or all the lines of longitude, are converging on the North Pole in the Northern Hemisphere, and they'll converge on the South Pole in the Southern Hemisphere. Lines of longitude down here at the equator are further apart, much further apart than they are from a physical distance standpoint than they are up towards the poles. From an angular perspective, there's still the same angular distance between them. However, because that's a further distance from where they conjoin, that distance is understood a little bit further at the equator than it is at the poles. In fact, it's going to be much further at the equator than it is the poles. Some other lines of importance are obviously the equator, which starts at 0 degrees latitude, the prime meridian, which is 0 degrees longitude, and it runs right through Greenwich, England. It also is reflected on the international dateline, which runs through the middle of the Pacific Ocean on the other side of the globe. The Tropic of Cancer and Tropic of Capricorn are at 23.5 degrees north and 23.5 degrees south latitude. It's significant. This is significant because the Earth is tilted at 23.5 degrees north and 23.5 degrees south. And it demonstrates the lines furthest north and furthest south that the direct sun is going to strike the Earth. The last couple lines of importance I want to bring up are the Arctic and Antarctic circles. The Arctic and Antarctic circles are at 66.5 degrees north and south latitude. And above those, in the winter time, above the Arctic circle, you'll have 24 hours of darkness, or 24 hours without seeing the sun. The sun will just barely be below the horizon when you're above the Arctic Circle. And the same thing with the Antarctic Circle during the summer months for the northern hemisphere, or the winter months for the southern hemisphere, which would be in June, July, August. You get 24 hours of darkness during that time. And we'll go into the seasons a little bit more as the class progresses. The measurements that we use for latitude and longitude are angular measurements. They are typically referenced in degrees, minutes, and seconds, and as this chart would show. So from some point of 0 latitude, 0 longitude, we can get an angular measurement from the theoretical center of the Earth out to a point on that position north or south of the equator, or east or west of the prime meridian. And that's how we establish our lines of latitude, or our points of latitude and longitude around the globe. If you're above the equator, all your latitudes will be north latitude. If you're below the equator, all the latitudes will be south latitude. If you're east of the prime meridian, all your longitudes will be east longitude, and all your longitudes west of the prime meridian would be west longitude, and they'll be designated as such. There's other ways that we actually can establish a method of location throughout the world. One is the latitude and longitude that we talked about before, but another one that's recently come out is called What Three Words. And what the program of What Three Words has done, it establishes and divides the entire globe into 3-meter squares. So it creates this addressable grid. And so within a 3-meter square, it associates some 3-word combination for each square. And that combination of words is unique throughout the entire globe. For example, I put in Flagstaff, Arizona here, and the 3-word combination comes up as camps, hoping, rope. And for that 3-meter area right in downtown Flagstaff, that camps, hoping, rope is the addressable address, or the 3-word address that can find that one particular 3-meter by 3-meter square throughout the world. And you could do this all over the place. There's an application that you can go out there and look at if you go to what3words.com and give it a try. It's an interesting, another interesting way to look at the globe.